Welcome back to Aeromotive. Today we're going to talk about control and mobility technology. Control and mobility technology can be broken down into three topics: avoidance, predictability, and awareness. And today we're going to choose a sensor that does all three, and that's your proximity sensor. They fall into a few categories. There's inductive, capacitive, photoelectric, and ultrasonic. Proximity sensors detect the presence or absence of objects using electromagnetic fields, light, and/or sound. There are many types, each suited to specific applications and environments. The ultrasonic sensor has two parts: a transmitter/reducer. This emits a very high-pitched sound. The sound waves travel through the air. The human ear cannot hear this sound, and if you look close enough there, you can see a tiny speaker inside the transducer. It also has a receiver. The receiver receives the signal after it has bounced off of nearby objects. So the sensor sends out this signal and determines how long the signal takes to get back. If the object is very close to the sensor, the signal comes back quickly. If the object is far away from the sensor, the signal takes longer, and if it's too far away, it doesn't come back at all. So it takes this signal and it converts it into an electrical energy. And that electrical energy then sends itself to processors and microcontrollers. And then through an algorithm determines the distance. So today's proximity sensor is the ultrasonic sensor. It uses sound waves to determine distance, in some cases size and direction. That's called echolocation. You might be familiar with it. Some doctors, prenatal doctors, use it to determine the well-being of a baby. Bats and dolphins use it to determine target. So let's take a closer look at where you might find it on an automobile. The use and location of these sensors varies from front, side, to rear vehicle. Some of the components are systems that use this type of technology: right-hand blind spot monitoring, cross-traffic monitoring, brake assist, forward collision avoidance, and of course, adaptive cruise control. And you can see by the smart board how the interactive these sensors can be to your vehicle. Each one of them providing an input, and at this particular speed, you can see how each one of them provides data. Given the location of these sensors, they're susceptible to collision. They're susceptible to corrosion, scrapes, bumps, and of course rodent damage. The signal pathways from these sensors travel through the harness assembly, and since we're dealing with radio waves, there is a chance of interference. So what they like to do is shield the cable. What do you do when you have a damaged cable? Well, as long as the damage doesn't exceed 1 inch in length and you don't have more than 25% of the shielded missing, you can apply shrinkable tubing. If you exceed this limitation, Aeromotive can manufacture a complete shielded cable assembly with connectors on either end or just the assembly itself. So there are some alternatives for you, some repair options, but again, you need to know your limitations. I hope this helped, and thanks for tuning into Aeromotive. Have a safe day.